Hi everyone, welcome to the channel Maths for Me and You. Let's learn maths together. Hi all, today what we are discussing all about is irrational numbers. What is an irrational number? Irrational number is a number which cannot be written in the form p by q, where p and q are integers and q not equal to 0. Let's see some examples of irrational numbers. First of all, we know that root 2 is an irrational number. So we can write root 2. Also, of similar types are root 3, then root 11. Also, we can write root 18. These all are irrational numbers. Then pi. Pi is an irrational number. Also, numbers connected with pi like 3 pi by 4, pi by 7. All these are irrational. Then next is decimals. Non-terminating, non-recurring decimals are irrational numbers. What are non-terminating, non-recurring? They are not stopping, not repeating decimals. You can see two examples here, two decimal numbers given here. Both are not stopping, that means non-terminating, non-repeating. Now, here comes a question. All root numbers are irrational or not? What's your opinion? Let's check. We can find the fact. First of all, what is an irrational number? A number cannot be written in the form p by q. That means cannot be written as numerator and denominator, where numerator and denominator, that means p and q, both integers and q not equal to 0. So we cannot write, if a number cannot be written in the form, then we say irrational number. Let's start with root 2. Root 2 we can write as numerator denominator. How? Root 2 by 1. And what is root 2? Is it an integer? No, it's not an integer. It is not an integer. That means the condition is not satisfying. So we can say root 2, is it irrational or rational? Root 2 is irrational because we cannot write as p by q, where both p and q are integers. So here we write root 2 is an irrational number. Next we check root 3. First write as numerator denominator. Root 3 by 1. What is root 3? Not an integer. Same like root 2, we can write this is not an integer. So the condition does not satisfy here. It shows root 3 is irrational. Next is root 4. But what is root 4? Root 4 is equal to 2 because 4 is a perfect square. When we take the square root, we get 2. And 2 is an integer. Also the denominator 1, it is also an integer. That means we can write root 4 as numerator and denominator like p by q, and p and q are integers. This shows root 4 is a rational number. This is rational number. So here it is not like root 2 and root 3. Root 4 is rational because inside the root is a perfect square number. The first case root 2, 2 is not a perfect square. Also root 3, 3 is not a perfect square. Next let's check root 5. Is it irrational or rational? Root 5, that means 5 is not a perfect square. So we can write root 5 is irrational. Similarly, we can write root 6, root 7, root 8. All these numbers are irrational. Inside the root 6 and 6 is not a perfect square. We cannot find the square root as an integer. So root 6 is irrational. Same thing for root 7. Root 7 immediately we can write it is also irrational. What about root 8? Already we have told root 8 also irrational number, because root 8 means it is not a perfect square. We cannot find the square root as an integer. So root 8 also irrational. Next one, root 9. What's your opinion? Is it rational or irrational? Root 9 we can take the square root. So square root we can write as integer, numerator and denominator. That means root 9 is a rational number, because root of 9 is 3. 3 is an integer. 3 by 1, p by q form. That shows root 9 is rational. So we have many root numbers we have checked, and in those we can see some root numbers are irrational and some root numbers are rational. Those numbers with perfect square number inside the root are rational numbers, like root 4, root 9. All other numbers are irrational root numbers with not perfect square inside the root is irrational number. So the result, all root numbers, are they irrational? No. Next we can see decimal numbers. What about all decimal numbers? Are they irrational or rational? To check this, we will start with terminating decimal. What is terminating? Stopping decimal. Here 0.1, it stops after the point only one number. We can write this as 1 by 10. 1 is an integer. Also 10 is integer. That means 1 by 10 or 0.1 is a rational number. 0.1 we can write as p by q. So it is a rational number. Next decimal, 25.34. This is also terminating. It stops after 2 digits. 2534. This is the numerator, and the denominator we write here after the point 2 numbers. So the denominator 100. See the numerator and denominator integer by integer. So this is also a rational number. Next we consider the number 1. When we divide by 3, we get the decimal form as 0.3333, and it is a non-terminating decimal but repeating. And see, from right to left, it is equal to 1 by 3. That means this decimal we can write as p by q. So this is a rational number. From the above mentioned examples, we understand that the decimals which are terminating or non-terminating, repeating, these type of decimals are rational numbers. Next we can see the decimal form of irrational numbers. Consider decimal 2.34021784, and it's not terminating, non-stops. And see the digits, they are all different. So this is irrational number. Non-terminating, non-recurring. Consider one more example, 0.2416348821, and it continuously going. Is this rational or irrational? It's non-terminating, non-recurring, so it is an irrational number. All non-terminating, non-repeating decimals are irrationals. Let's look the decimal form of root 2 and root 3. You can see both are non-terminating, non-recurring decimals. Now we come back to our question. All decimals, are they irrationals? No. Which decimals are irrationals? Non-terminating, non-repeating decimals are irrational numbers. We have already discussed that pi and the numbers connected with the pi are irrational numbers. For example, 3 pi by 4 is a number connected with the pi. Again, pi by 7, 2 pi, all these numbers are pi or pi connected with numbers. Okay, and what type of numbers? They are irrational numbers. What is the decimal form of pi? pi is equal to 3.14159265, and you can see this is a non-terminating, non-recurring decimal. So pi is irrational number, and when we check the decimal form also we get non-terminating, non-recurring. After all these discussions, we come to the conclusion that irrational numbers, the set of irrational numbers, when we look, we can see three different types of numbers. First, we can see there root numbers, and inside the root, not a perfect square numbers like root 2, root 3, root 5, root 6, root 7, root 8, then root 10, root 11, this type of numbers, because under root numbers are not perfect squares. And we can see pi or numbers connected with pi, like pi, 2 pi by 3, 17 pi, this type of numbers. Also we can see decimal numbers, and when we see the decimal numbers, they all are non-terminating, non-repeating decimals. And here you can see three examples. All the three examples given here are irrational numbers because they are non-terminating, non-repeating or non-recurring decimals. Irrational numbers are either of the form root, where under root numbers are not perfect squares, pi or pi connected with numbers, or decimal numbers, non-terminating, non-recurring. Hope this video is useful to you. See you with more videos. Thank you.